All right, so now in this section, or this video, this section, we're going to just focus on graphing logarithmic functions. All right, now in order to graph these, it's going to be important that you understand that the 2 raised to the x power is equal to y, so our exponential equation is the inverse to log base 2 of y is equal to x. All right, so it's going to be important for you to be able to rewrite these in different ways because we know how to graph this. We've done this, we feel comfortable with this, it's easy. To make this one a little bit easier, then we want to rewrite it at times. All right, so let's go ahead and we're going to graph, there's going to be an example in a second. So the first thing is a logarithmic function, highlight that in green. A logarithmic function is an inverse of the exponential function, exactly what I just talked about in the last slide. All right, so they're inverses of each other. And the graph in red shows y is equal to 10 to the x power, and we can do that one pretty easily. We put 0 in for 1, we know 10 to the 0 power is equal to 1. Or put 0 in for x, 10 to the 0 power is equal to 1. We raise 10 to the first power, then it's equal to 10. So here's our graph of our red equation. I'm now highlighting black. Remember, this is called an asymptote. It never actually touches that that line, but it gets very, very close. All right, now, the inverse, we know our x and our y switch. So then the inverse of the red graph, we simply would switch our x and y. So we had a 0 in for x, now it's a 0 in for y. We had a 1 in for y, now it's a 1 in for x. We had a 1 in for x, now it's a 1 in for y. And we had a 10 for y, now we have a 10 for x. So we're able to plot these 2 points based on our exponential function. And remember, just like before, our domains and our ranges switch. So the domain of our red, what could we substitute in for x? We can substitute all real numbers. Because we can have negative and positive powers. All that means is whether or not our 10 is staying in our numerator or our 10 is then dropping below if it's negative 1. So we can have all real numbers. However, since our graph never crosses that y-axis or never touches it, our range is y is greater than or equal to 0. Because remember, this is an asymptote. It never actually touches our x-axis. It gets very, very close, but never actually touches. So then our inverse is we switch. So our x and our y switch. So our y was greater than or equal to 0. So then our domain in our inverse has to be x is greater than or equal to 0. And then our domain was x is all real numbers. So then since we switch, y is all real numbers. And we can see by our graph that that is true. All right, so now let's go ahead and let's actually graph a problem. So they tell us to graph y is equal to log base 3 of x. I personally think it's going to be easier for us to graph the other way first. So let's rewrite this as an exponential. And we can say 3 raised to what power is then equal to x. And remember, our inverse, we're switching our variables, so it becomes 3 raised to x is equal to y. So there is our inverse. And now let's just create a table, and we'll do this graph in red. So we'll do 0, 1, and that's it. We don't have enough room for 2. So we'll do 2 for the point, but we don't have enough room to actually graph it. So when x is 0, y is then 1. When x is 1, y is 3. When x is 2, y is 9. So we'll plot the points 0, 1, 1, 3, and then the other one would be 4, 5, 6, 7, 8, 9. It'll be somewhere up here, right? And remember, this exponential function graph gets really, really close to this x-axis, but never actually touches it. So we know it looks like that, right? Our logarithm function then, our x and our y values just change. So the 0, 1 becomes 1, 0. The 1, 3 becomes 3, 1. And then our 2, 9 becomes 9, 2. So we'll plot these points, 1, 0, 3, 1, 1, 2, 1, 2, 3, and 4, 5, 6, 7, 8, 9, 1, 2, 3. It'll be somewhere up here. Or 2, I'm sorry, that's 2. All right, so there is our graph. And then since here our x-axis is our asymptote, and our logarithm, our y-axis is our asymptote. So this is what our graph will look like. So it'll get very, very close to that y-axis, but never actually touch it. All right, so there's the graph of log y is equal to log base 3 of x. Now, it says identify the domain and range. Well, for the red graph, our domain for our exponential, we know x is all reals. And our y value, in this case, since there's no transformation, we know, our range, our y values, you know y is greater than or equal to 0. So then for our graph of our logarithm, we know that our domain and our range switch. So x is now greater than or equal to 0, and y is all reals. Right, now, something that happens is this graph, these graphs, when there's no transformations that are being done, they reflect about this line here. And that blue line that we just had is the equation y is equal to x. So our logarithm and our exponential equations will always reflect about that line. Right? So it'll be a perfect reflection of each other. Right, that's it for this video. That's it for graphing and finding the domain and range of a logarithm.